Here's an engineering hack for factorising quadratics of form ax squared plus bx plus c. Makes it much faster. Firstly, a little recap. Quadratic is a polynomial of degree 2 where the highest power of the variable is 2. Here's some general forms. Y is equal to ax squared plus bx plus c. We have coefficients a, b and c, where c is the constant. Here's another example. Y is equal to 2x squared plus 3x plus 5. So here a is 2, b is 3, c is 5. Here's another example. Y is equal to x squared minus 3x minus 2. Here the coefficient of x squared is 1, the coefficient of x is minus 3, and the constant is minus 2. And finally, y is equal to 6x squared plus 5. Here, the coefficient of the x squared is 6. There is no x, so the coefficient of the x is 0, and the constant term is plus 5. Example. Solve the following. 6x squared minus 5x minus 4 is equal to 0. To solve this, we need to factorise it. But the problem is that because the leading coefficient is greater than 1 and is not a prime number, there are multiple possibilities. 6 has factors 1, 2, 3, and 6. So it could be 1 times 6, 2 times 3, 3 times 2, or 6 times 1. In addition, the constant, which is 4, is not a prime number. That has factors 1, 2, and 4. So the last two terms in each of the binomial expressions could be 1 and 4, 2 and 2, or 4 and 1. In addition to that, because the constant term is negative, one of the brackets has the addition operator and one of them has the subtraction. So that doubles the number of possibilities. Here they are here. And with each of these, if you take the first two respective terms, they will give you 6x squared. The first one gives us 6x times x, 6x squared. And if you take the last two respective terms, plus 1 and minus 4 multiplied gives minus 4. The first two respective terms give 6x squared. The last two respective terms give minus 4, as is the case with all of these possibilities. But only one of them will give us the minus 5x in the middle. So if we look at the first one again, we multiply the respective outer terms. 6x times minus 4 is minus 24x, and the respective inner terms, 1 times x plus x. So we have minus 24x plus x. So this will give us, when we add them together, minus 23x, which is not minus 5x. Therefore, this isn't the correct factorization. How to choose which one? Here's an example. Solve the following. 6x squared minus 5x minus 4 equals 0. We take the 6 from the x squared and we bring it to the constant term, multiplying that. So we end up with x squared minus 5x minus 6 times 4. That becomes x squared minus 5x minus 24 equals 0. Now to factorize. Well, that factorizes easily because 24 has 8 and 3 as factors, which do have a difference of 5. So it's x plus 3, x minus 8 equals 0. That means x is equal to minus 3 or positive 8. Now, final step, to divide through by the original leading coefficient of 6. That gives us x equals minus a half, x equals 4 over 3. These are the roots. Brief recap at this point. Recall the quadratic formula gives x is equal to minus b plus minus root b squared minus 4ac all over 2a. Using the example we had before, 6x squared minus 5x minus 4 is equal to 0. If we were to solve this using the quadratic formula, we have a is 6, b is minus 5, c is minus 4. From the formula, we get x is equal to 5 plus minus the root of 25 plus 96. That's b squared minus 4ac. All of that over 2a, or 2 times 6, 12. That gives us 4 over 3, or minus 1 over 2. Now, let's use our hack. We get x squared minus 5x minus 24 equals 0. Here a is 1, b is minus 5, c is minus 24. Using the formula, we get x is equal to 5 plus minus root 25 plus 96. Same as before, all over 2a. This time a has become 1, so we get all over 2. That gives us 8 and minus 3. Once we divide through by the original leading coefficient of 6, 8 and minus 3 become 4 over 3 and minus 1 over 2 respectively. Those are the roots of the original quadratic. So why does this work? Here's our original quadratic. It has coefficients a, b, and c. ax squared plus bx plus c. If we change that to this quadratic, x squared plus bx plus ac, the coefficients have changed to 1, b, and AC. How does that affect the quadratic formula? Let's have a look at it. Minus b plus minus root b squared minus 4ac on 2a. Now, if we look at the quadratic formula for the lower quadratic, notice that we only have 1 as the coefficient for the x squared term. So the denominator in this case will be just 2 times 1, or 2. So in order to make it identical to the above, which it is in every other way, we just need to divide these roots for this lower quadratic by a. Following on from the previous slide, we have a graph here of 6x squared minus 5x minus 4 and x squared minus 5x minus 24. The two roots labelled in green, x equals minus a half and x equals 4 over 3, offer 6x squared minus 5x minus 4. The two blue roots, x equals minus 3 and x equals 8, are for x squared minus 5x minus 24. Recalling from the previous slide that these two equations, the quadratic formula, differed only by the lower one not having a in the denominator. In this case, a is equal to 6. If we take the quadratic formula for the lower quadratic, all we need to do is divide the denominator by 6. That means we're dividing our roots of minus 3 and minus 8 by 6, which will give us minus 1/2 and 4 over 3. Summary. We're given a quadratic with a greater than 1 as above, and we're asked to find the roots. Step 1. Divide the leading term by a and multiply the constant term by a. Step 2. Find the roots of this new quadratic. Step 3. Divide these roots by a, and that's your answer. Finally, here are 3 examples to practice with. You can pause the video to read them. In the next video that I do, I'll be showing the answers to these.